Our second speaker is Mark Hearn, and I have to share a little story. Mark and I only met for the first time today. We've spoken on the phone, but we only met for the first time today. But I normally have a hard time remembering names, but I won't have any hard time remembering your name because one of my best friends is named Mark Hurd. So it changes by one letter. So if I slip and call you Mark Hurd, then that'll be the slip on my part. So with that, let me introduce our next speaker, and Mark, take it away.
Thanks, Eric. So I guess the first thing I wanted to touch on is exactly earlier on when Eric asked me just how do you pronounce your company's name, right? So the company's name is Irdeto. And so if you see the little green dot in the logo, IR is Dutch for engineer. And our original founder, going back almost 50 years, his last name was Den Toner. And so Irdeto actually was born by an engineer who was able to create conditional access systems that were then sold into the pay media industry. And so when we say we've been around for 50 years, it's been actually working with companies that rely on having a strong ecosystem of embedded devices spread amongst all of their different customers where they have zero trust in those customers. And what that actually does is brings in very unique challenges to the security equation. So if you take a look at the things that we've done over time, 5 billion devices and applications that we've secured up till now. We're the inventor and key patent holder of white box technology or white box cryptography. I'm not even sure within industrial IoT, white box cryptography is all that well known yet. And yet it is an absolute staple in multiple industries because white box cryptography allows standard algorithms to operate in a mode where you don't trust the endpoint. How can you make sure that that software execution on the endpoint doesn't reveal any keying material or a digital key or things like that? So white box cryptography is something that we've done elsewhere, and we start to see a great applicability within industrial IoT type markets. As I say, we're originally from the Netherlands, but there's a major office where I come from in Ottawa, a fair bit colder there this morning than it was here. And a technology that grew up in Ottawa is called cloakware, and it is intended to operate primarily on a software basis, where what you want to do is create trust within that software. You already have hardware security in place, so how do you lock the software to it? Or maybe you have software that was originally designed for a device, but now it's being moved onto another platform. How do you make sure that that software can be ported correctly and still maintain its trust? And I think where we actually see an incredible amount of opportunity for hackers that are versed in software hacking techniques is with all of the innovation that we are starting to benefit from. Anything from augmented reality, advanced robotics, these are things that we're making use of in our factories today. But when you start to look at machine learning, you think about digital twins. I mean, digital twins primarily is a data model, but that data has to be processed somewhere. Is it processed in the cloud? Is it at the edge? It's software that's managing that. So how can you ensure that the software doesn't become an attack point? So what we've been doing over the last year and a half to 2 years as we've really pushed into trying to become more well-known within industrial IoT, particularly into manufacturing, things like automotive, a little bit of healthcare as well we've been doing. We've been trying to increase people's understanding of the threat against software and trying to expand the attack surface beyond just vulnerabilities. Right? A lot of us today, when we think about cybersecurity, and we joked about this at lunch, cybersecurity is becoming this one big, huge thing that covers everything from firewalls to you name it. When we think about protection of software and a secure development process around software, it's all about, did we do a code inspection? Did we do static analysis? Is the code relatively free of bugs? And I think what we're doing is we're bringing from other industries where that's not good enough. We're trying to say there is a rising tide that's coming in of hackers that can bring code into a hacker's tool, IDA Pro, now goes for less than $2,000. You can pick it up fairly easily, and all of the software is readable as a book. It's right there in front of you. And oh, look, there's a decrypt operation just written there, string search. It becomes very easy. They don't need to wait for vulnerabilities. And I've had this discussion with a number of companies, but they're not necessarily bought in to that concern yet. You know, they're still trying to wrap their brains around the analysis side. And there was a great presentation at S4 2 weeks ago. I was there. Actually, I encourage anybody to go look this one up because there's multiple press releases around it. But Trend Micro created one of the best honeypots I've ever seen. They went through the whole 9 yards of creating a shell company with factory space that they've rented. And what they did is they created this thing to see how does the hacking community infiltrate into a manufacturing environment. And, you know, they found lots of guys coming in and grabbing stuff, and they would test it and realize, well, that hacker doesn't know what he has. So that's just a straight, I attack any company because it was a weak company kind of attack. But they found documented proof of hackers that were able to go in, zeroed right into a particular directory, grabbed a particular file or a particular executable, and knew that that shut down that factory line. And so what we're starting to see is this rise of very sophisticated attackers that are moving beyond those vulnerabilities. They're looking at how can I get a piece of code and maneuver through that code to identify what I'm looking for. Combine that with the increased connectivity that we're starting to see. I mean, connectivity that is bringing huge efficiencies. It's bringing us more business than we've had before. That's why we're doing those innovations. But we need to start to look at where we bring the trust back into them. So what I want to do is kind of run through a couple of different steps that we've talked about. And these are a bit generic, but we'll talk about them in a sense of this is a starting point of a conversation. One of the key things when you actually start out looking at your overall architecture, and I think of that in terms of the ecosystem, not whether I need to secure a device or secure a connection to the cloud, but rather how does the whole thing go together? What are the different threats that you're worried about? What are the assets that you need to protect? If you're actually using a multi-vendor environment, how is the trust between one vendor and another vendor? When your critical data is being collected, and you're collecting it from multiple different pieces of equipment, how are you actually trusting that that data coming in is something that you can trust the analytics that come from it? Does bad data actually turn into a bad analysis? And these are the things that you need to consider. Then once you have those assets, it's time to think like a hacker. And I apologize, this is a much longer story that I tell in some of the other presentations that I do called Think Like a Hacker. But in essence, this story was it's all about the context. If you have an engineer that puts together a lock on the front door of a house, right? They create it, it's made of all of the right materials, they're using the latest locking mechanisms, maybe it's even digital. That house is secure because I put a lot of effort into making sure that that lock was secure. Well, an architect would actually come look at that house and say, well, it's just a wooden frame around the door. I can kick that in easily. Or the window is open, I can get into the house that way and I can steal the jewels that way. So the architect looks at it slightly differently. Hackers actually think completely separately. They'll drive down the street, not looking necessarily at any one particular thing, but rather what has the best combination of profitable asset to get their hands on, something that they want to target, combined with something that they think they can get into. And in the story, I talk about the shed that has the ladder in it, protected by the $3 padlock from Home Depot, and how, for the sake of all of the sophisticated equipment that went onto that house, it was the lock that ended up protecting the house because the ladder could have gotten to the second story. So thinking like a hacker changes the way in which you look at the assets that you're deploying into your ecosystem. This one comes up all the time, design security and from the start. And I think this goes back a little bit to the discussion we had earlier on. The best savings you can do is by actually fixing the problems and addressing the concerns during your upfront analysis, identifying your requirements, identifying who your adversaries are going to be, and identifying that early in, and continually working on that. The security software development lifecycle, I had to throw this one in. This is my trying to, move the thought leadership further down the road. A lot of really good steps in here that most companies are doing. But if you think about it from a maturity standpoint, many companies are still kind of in that phase where, we're relying on vulnerability assessments and then pen testing. And much like you said, if you're finding the problem during the pen test phase, you're already in danger, right? That to go back and have to fix that or change it is so expensive. So how many times do you just simply, let's wing it and see until the next release comes? So what we need to do is think about things from that more holistic aspect and start to add in some different elements like software protection and monitoring, telemetry, and starting to look at monitoring of the dark web. What is the activity that's coming against our company? How do we start to anticipate the knowledge that the hacking community is building up against our company? And then we monitor and repeat. So we're quite familiar with data collection, where we look at a lot of our different pieces of equipment. We'll monitor whether it's efficient or not. How's its connectivity? Is there error states on it? We also have that ability in the security community where at runtime, we can be identifying analytics from devices that tell us when a device is under threat, even before the hack occurs. That's technology that exists. But it's technology that we could be using to help thwart an attack before it occurs and identify where an adversary may be coming in. So it's just 5 quick steps, a bit high level, but I think this is where a conversation is to be had amongst the 3 of these. So our goal is to identify businesses, software criticality, and the need to protect that.